So when you look at pi as equal to 1 times infinity, what is infinity? Infinity isn't necessarily definable, right? It's improbable. So 0 equal to 0.000, repeating, ending in 1, I call that null infinity. And because if you take infinity minus infinity, you're going to find that, say, infinity is an infinite set of 1 with an infinite, or just 1.000 repeating. And then that 1.000 minus infinity would equal what? 1 becomes a 0, point 0, all ending in 1 minus that ending in 1, which equals just an infinite set of zeros. But if you do that again, then you equal 0.9 repeating. And so you equate that 0 to that infinity, and you say that minus itself then equals 0.9 repeating. And so you end up with 0.00 infinite ending in 1. Well, then infinity minus infinity is equal to an infinite set of zeros ending in 1, which is a null infinity. So that is the smallest theoretical value. You cannot get any smaller than that. That's as small as anything gets. Now, how come an infinite number can have an ending? Why is that? Well, you can have an infinite number with a start. So logically, you can have an infinite number with a beginning. If you take 1 and you draw 1 out in the opposite direction, you add 1 infinitely. It gets infinitely large. And the one law of philosophy, for something to exist, there must be nothing for it to exist in. No matter where you vector is just your one point. And so in my number theory that I designed, which honestly looks a lot sillier until you understand all this, is that this is your vector. You have an infinite set of zeros in this direction, and you have an infinite inclination in this direction. And so that rationalizes infinite numbers, because you're able to vector just in a number. You don't need, sure, you can do it with graphing theory and all that other stuff, but that stuff confuses me, okay? So that's why I figured all this out, because it's fun for me. It's nonsense. So when you look at n1 as being n function 1, right? So infinity minus infinity is equal to an infinite set of zeros ending in 1. You have your null infinity, which we as a standard mathematical system consider that to be zeros. All infinities around it, because it makes life easier. So n function 2 then would be that infinite set plus itself again. So then you're adding null infinities. And you add and add and add null infinities until you reach a point where you rationalize that. So n function n is equal to pi. And if pi is 3.141519, right? And then forever and ever and ever, you got to understand, like, it is potentially plausible in some abstract theories to add up to pi. If you knew where the beginning of pi is, then you would know where the end is, and the end is 3.14. However, what's going on the other side? So you have an infinite series in between these two, and that's what my whole number theory is designed around, rationalizing pi. So your vector, your main vector here, can be any number you want. However, pi is running in this direction, and pi is running in that direction. And that runs all the way up to 3.1415. This runs all the way down to the ending of pi, which is basically, you have your decimal points. There you go. And then if you add that with the vector, and then you have your what is the fundamental value, because your decimal place would this be there. And what this helps you rationalize, something that has bothered me in number theory my entire life, is rounding numbers. I hate rounding numbers. It drives me crazy. So every time we round a number, we're pretending we're exact. But we're not exact. What we are is making excuses for the flaws in things. Because we can't actually calculate infinite numbers unless we rationalize them. And rounding up rationalizes an infinite number, right? So 0.9 repeating rounded up is just 1. However, what happens to that null infinity? Where is that one little number that says that there isn't a straight line here to form a circle with this unbelievably small angle? So ideally, it would be a whole bunch of circles that form a line and a curve with such great circumferences that there are no angles. And that would be the exact counterintuitive to what trigonometry approaches in calculating curves. So, going beyond how to rationalize pi, how do you add up to pi? Logically, if pi is equal to 1 times infinity, or you could look at it like 0 as a null infinity, that pi and null infinity are the same thing, essentially. Because pi has to have an infinite amount of degrees to create a perfect curve. There cannot be any angles at the opposite end where the circumference exists. There is no actual angle because there's always a curve around a circle if you draw this from the center. So if you draw a center right, come out, there's your curve. This does not exist. That angle doesn't actually exist. Pi is basically that angle in its own way. It's telling you how far to zoom in so that that angle exists. And that's kind of what pi is. So you zoom in further and further and further. Your degrees never change. However, the length of this is always defined by what pi is capable of existing as in number 3. And when pi, I know this sounds fucking crazy, right? It's just, you add up to our standard model of pi, and then you can unify all the fields. If you understand how to add up to that, if we have a beginning and an end, which we already have an end, 3.14, so we set our theory there. This is what we're looking for. We can set our vector here. This can exist as any probability of any size, any quotient, any rationale, right? This could be in between 3.14 and the ending of pi if you wanted it, if you figured it out, if you have those last 3 numbers. As we know, since pi is infinite, that number exists in it somewhere. And that is where you rationalize pi. Where is 0, 0, 1 within pi to stop it there? And then all the numbers in between these two are your vector. And that is basically your size quotient. That is your fundamental value in how you can add up. But that number doesn't necessarily work, right? And it takes, what, decades to calculate that with a standard computer, except with quantum computers. Geez, who knows how far that's going to go until we find 0, 0, 1. But is it 0, 0, 1? Somewhere within pi is going to be an infinite set of zeros ending in 1, since the number is theoretically infinite. And that would be your null infinity. And that would define pi. That all numbers ahead of that would set your decimal point here, and then it would end. And technically this would equate to 1. 1 pi 0.00 null infinity. So number theory is really fun like that.